Good day to everybody that is watching this video. My name is Brandon and my partner is Sina, and together we form Group 10 of the EEE3097S design project. Now, what is EEE3097S? Well, this is a course offered by the University of Cape Town and is the Electrical and Computer Engineering students' design project. There are other course codes which represent the other streams of engineering's design project. However, this specific course code is for the Electrical and Computer Engineering students, otherwise known as ECE.
A quick introduction to the project. We need to design a system that can read data from an IMU, compress and encrypt this data to be sent to a separate device. At this device, the compressed and encrypted data needs to be decrypted and decompressed. The output of this process needs to be the same data that was initially read from the IMU. This system will then be placed onto ice buoys, which are measurement devices placed in the Antarctic region. They measure the environmental conditions that form and affect said ice. Alas, with all designs, we do not always have everything required to complete the design to the exact specifications. In our case, the actual IMU to be used is the ICM 20649. Unfortunately, we do not have access to this IMU, therefore have to make use of the WaveShare SenseHat B, which also contains an IMU module, however not the one that is required. There is also the point that we do not live in Antarctica and do not have the means to travel there, therefore cannot do actual real-world tests that would properly validate our design. However, with the limitations aside, we began our design process. As a first step, we held our first meeting. We discussed the ways that we would go about our design project. Following this, we began our paper design. This consisted of a lot of research. We needed to gather the relevant data, define requirements and specifications based on the design brief, and design an overview of our system solution. Following this, we began our first progress report. This consisted of simulations and initial coding. At this stage, we did not have access to the WaveShare SenseHat, and so had to make use of simulated data in CSV files. Following this, we began our second progress report. This consisted of hardware testing, as we had access to the WaveShare SenseHat mentioned previously. We conducted a series of tests to ensure that our system would work in the given scenario. Following this, we compiled our final report and this demonstration video. We will now move on to a demonstration of our system.
This is a demonstration of our send-in protocol code. The purpose of the code is to read data from the IMU, compress, and then encrypt it. For the purpose of this demonstration, we have set the sample size to 30 to save time on this video. When the code is run, which will be done now, the Pi will start reading data from the IMU. This can be seen as such. The values displayed are from the various sensors of the SenseHat. This includes accelerometers and gyroscopes. Here is the IMU on top of a Raspberry Pi. When the Raspberry Pi and IMU system is moved as such, you will notice that some of the values begin to change. This is to be expected as the sensors are sensing a change in their environment. I shall do so again for the purpose of this demonstration. Once the data is finished recording, it will be sent to a file where it has been encrypted. This file looks as such. As we can see, it's complete gibberish and no one can accurately tell what it is. Therefore, the encryption algorithm has worked.
It is difficult to show the functionality of our compression section. Therefore, we have included some of the results from our final report of our compression tests. These include images showing the comparison between the data sizes of the original input data and compressed data. Data.txt represents the original input data, where compressed.txt represents the compressed data. As can be seen from these images, the compressed data is smaller than that of the original input data. Therefore, our compression section has worked. On a final note, I would like to leave you with some links in the description. These are to a short article on ice buoys, as well as to our Git repository and the subsection of this repository containing our report. Do note that the report is long, so will take some time to read. Thank you all for watching this video, and I hope that you have a good day.